6 to 7 off, 7 to 8, 8 to 9 off, again 9 to 10. This is your clock. But your signaling, I mean what we call, your system is working from this point to this point. They should be same height, okay? So during this, from here to here, you understand this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I did wrong. 1, 2, 3, 4, 6, 9. And 1 minute. Let me write 1, 2, 3, 4, 6, 7, 8. Okay, let us. This is 9. And again at 10 you will get. Okay. Now, according to examiner, what is the counter or positive edge trigger? So how many positive edges occur here? 1, 2. So what is the output of the counter? First clock 1, 2, 3, 4. So the counter will count 4. That is 1. That is no. Okay. Actually, I have made some questions. So this is not made by me, but I have collected long back somewhere. I forget where I collected, but I made some questions similar to this. Problem is they are not available in the typed part. So I am getting into some few 40 questions they typed right now. Sir, about the clock, how we know? You don't know. He has given it. 1, 2, 3, 4, 5. He has given it. Google. Thank you. So let's move. Yeah, this is good question. We do it today only. This one I gave at homework now. I will explain that separate part. I will discuss it. Just wait at the end of the class. This is also important question. Okay. Now this question. I'm sorry, I haven't seen. I thought it is negative edge triggering. I'm very sorry. Actual question is 1 minute. 1 minute. Positive में question is possible. Yes, positive में possible. C is the right answer. Okay, C is the right answer because these two are negative edge triggering. Your answer must be either B or C. In that also, I marked C only, or you marked C. Okay, I gave wrong. Don't worry. Don't. Now, one simple shortcut to do this. Don't do everything. Here the question is like this. It should be like this. Every clock 0, 1, 0, 1, 0, 1. First clock you should get 1. Remaining clocks 0. Okay. So if you see D flip flop input is 1. What is the output? So this is not your answer. So compulsory C is the answer. But let me prove it. First read the question now. Just this by elimination of option 1 minute mein answer aayega. Now a digital block is shown in the figure is realized using two positive edge triggered D flip flops. Two positive edge triggered D flip flops. Okay. So we eliminated the negative. Assume that for t less than t naught both of them are 0. The circuit in the digital block is given by. Okay, this is your clock. Okay, we have applied to digital block. First clock pulse I should get 1, remaining all clocks I get 0. That is the required condition. So for that what to do? So let me, I mean from options we can eliminate. Let me prove it also. How to do analysis also I will show you. 1 minute. Let this into this. And here we have one thing. Okay, this is D1, D0, U1, Q0, Q0 bar, Q1 bar. This is your initially this is the condition. Now what happens when you apply the first clock pulse? What is the output you will get? For this, what is the input? I told analyze from rightmost flip flop. What is the input? 1. What is the input here? 1. So this will be replaced by 0. You may have the doubt earlier I told now analyze from rightmost. Why? What is the reason? If you analyze from this side, first 1 comes, 0 comes. Then this 0 you keep it here, then you will have, there is a chance of confusion whether to consider 1 or 0 as the input. That confusion can be avoided if you analyze from this side. So first clock pulse is done. So second clock pulse, now what is the condition? See here, second clock pulse, what is the input to this now? 0. You get the same. What is the input to this? 1. You get the same. Again, third clock pulse. Same input. Same input. It will be same. That is first clock pulse you get 1, remaining all. Okay? Yes or no? Right. So let's move to the next question. In this question, please read this question. Which of the following, for each of the positive edge triggered JK flip flops used in the following figure, the propagation delay is delta t. Okay, like TPD, it is delta t. You have J0, K0, J1, K1 connected to 1. Okay, so here positive edge triggered flip flops. Q is connected, positive is connected. What is this? Up or down? Tell me, yeah, very good. It is the 2 flip flops, so mod 4 down counter. What is the total delay? N times delta t. What is the output time period? 4 times t. Okay. 4 times t clock. Because it is mod 4, it is f not equal to f clock by 4. You know this basics, right? So the question is same thing. He asked you what is Q1. Q0 is the LSB. This is Q1. Q1 waveform. We already discussed the timing diagram. From that you can say he is saying 2 time period. Correct or not? What is the time period of the output? So it should be 4t. This is wrong. Either this or is your answer. You only tell me what is the delay? 2 times delta t. So what is the right answer? T plus delta t, t plus 2 delta t. What is the right answer? That's all. It's a simple question. Here is given as delta t. Here it is given as 2 delta. It is a asynchronous counter, so it is having 2 NTPD is the formula. If you have n number of flip flops. This question everybody knows it. Flip flop is used to store 1 bit of information. Race condition occurs when both the inputs are 1. Master slave is used to store no. It is only 1 bit. Okay. A transparent latch consists of D flip-flop. All 1 to 4 are correct. You may have the doubt, sir, race around is occurring only in JK. But according to the given options, you should assume it as a JK as we don't have any choice. Okay. Yes, tell me. Here T clock and T are same only. My notation is T clock, examiner notation is time period T. T clock or T both are same only. 4T or 4T clock. It is just a name difference. That's it. Okay. This question, ask it which question? Yeah, this is a printing mistake. Don't worry. This is only your time. Okay. Okay. Thank you. This is done. Master slave configuration is used to store only one bit of data. Master and slave copies the same. Slave copies master. This is done. This is done. Yeah, we will come to that. Come back to that question. This is also done. I told only this, not this. Why? Because symmetry. Amitabh, what happened here? I told just now it occurs only in JK flip-flop, but in the options we don't specify anything, so we assume it as a JK flip-flop. I told that it will occur only in JK flip-flop. We also already done one question also earlier. Okay. Here BCD is not the right answer. 0 to 9 it is also, but it is not the right answer. Here this also not right answer. Last lecture we have done this. You remember or not? Doubt clearing session I have done. Yes, very good. This is already done in the class, Avneet. To just go through the last lecture. Remaining people, please tell me, we have done this or not? Last doubt clearing session, whoever attended, please tell me that. You attended, people? Okay, anyway. Don't worry. Means mod 10. This divided by 5 followed by divided by 2. This is also mod 10 only. Then you will get the doubt. 100 microseconds is to be converted into 10 microseconds. So time period, sorry, we should convert 10 into 100. T naught is equal to 10 times the time period of the clock. So F naught must be F clock by 10. What is the condition? It is a mod 10 counter required. Mod 10 counter required. BCD is also mod counter. BCD decade counter. This is also mod counter. And this is also mod 10 counter. So which of them is to be selected? This is wrong. This is only right. Both are there. Both is also wrong. Why it is wrong? I will tell you. You take mod 10 BCD. The BCD counter will count from 0 to 9. That is all zeros to all ones. After 9, it will again count from 0, 1 and so on. Here you take this Q3, Q2, Q1, Q0. So you observe here, your Q3 is having on for 2 clocks and off for 8 clocks. Yes or no? It is 0 for 8 clocks, 1 for only 2 clocks. So is it symmetrical or asymmetrical? Means it is asymmetrical. It is also mod 10. It will also divide by 10 only. It can also do 100, 10 into 100. That is true. But it cannot do what? It is not symmetrical. You understand this first point? It is asymmetrical waveform. On time and off time are not same. You don't get here 50% duty cycle. Symmetrical meaning is T on should be equal to T off. 50% duty cycle required. Now let's take the example of mod 5. Mod 5 is having all zeros to 4. Then again 0, 1, 2, 3, 4 and again 0. Now take mod 2. Mod 2 means only 1 bit, which is always 0. When this fellow changes, because this is given as input to this, cascaded. So when this changes from 1 to 0, this fellow will change from previous bar. When this changes from 1 to 0, it will become previous bar. So this is also some kind of mod 10 counter only, but not 0 to 9. It is counting 0 to 4, 8, 9, 10, 11, 12, again 0. Now you observe here Q3. In the Q3, what is the advantage here is on time is equal to off time is equal to how much? 5 time period of the clock. So it is what we call symmetrical. So here only one option will give you the right answer is Yeah, perfect square wave means on equal to on. So let me give you one more question based on this. Mod 2 means it counts 0 and 1 only. Okay, whenever its clock changes from 1 to 0, it becomes 1. Otherwise, it is 0. Only 2 states it is having. That's why it is called mod 2. If not symmetrically specified, you take both the answers, nothing wrong. Right? So let's have one question. Connect the let me start the poll. Just read. So what is the right answer? Ring counter is not the case because it is having not 50% duty cycle. But Johnson is having 50% duty cycle. I told already. Okay, ring counter duty cycle is not 50 na. Only one case it will give you 50. That is when your input is 0101 like that. Otherwise, it will not give 50%. It depends on the initial value. So mod 16 is 8 zeros and 8 ones. So definitely it will give you what we call symmetrical. This is cannot give symmetrical. Sir, it is written can give in question. What is that? I didn't get you, Nishita. So mod 8 followed by mod 2 anyway it will give. Ring counter, if you attend the lecture, this is the output. So here on time and off time are not equal. Yeah, if initial value is this, you can do. Only in this case it will happen. In general, not possible. Okay, I removed that. Okay, let's go. Here, what is the formula? F equal to F max. Formula is direct formula 1 by n times TPD. Here n is 4 into TPD of 1, that is 50 into 10 power minus 9, which will give you 5 megahertz. You have a 4-bit modulo 16 ripple count. Next, this anyway I have done in the class. This I will do. This question also we have done earlier. Now take JK flip flop, easy way I told you now 1 1 1 0 0 0 0 1. So what is J? It is A bar, B bar plus A bar B, which is A bar. Already I have done this in the class again. Here it is a toggle mode, initially 0. When you apply the clock, it will become what? What is Qn plus 1 here? J Qn bar plus K bar. What is K bar? Into Qn. It is Qn. What is this? A toggle. Okay, now let me go through this question. Listen. What is the answer I give? 0, 0. Now, here I will give you 3 methods to solve this question. So, method 1, it can be applicable to any synchronous design. 3 methods I will give you to solve this problem. So, the first method is, what are the initial values, man? Initial values are 0, 0. 0 means here 1. This is the initial value. Now, don't, okay, listen here. Listen. When you apply the first clock, what is the input to this flip-flop? It is a 0. This is how much? 1. 0, 1 will give you, what is the output? 0, 1. Already here, what is the input? 1, 1. So, it will give you previous bar 1, 0. So, this is the case of the first clock. This 1 will go back here. This is how you need to analyze without confusion. Okay, first you take this input, give the output. Take this input, give the output. Take this next input. Ready the inputs. Now second clock. So when you apply the second clock, by this time, what is the input here? 1, 0. You will get 1, 0. What is the input here? 1, 1. You should take previous bar. Okay, this 0 will go back here. Next. Third clock. What is the input here? 0, 1. What is the input here? 0, 1. That's all. So after 3 steps, wherever you have started, same is coming back. So that's why it is mod 3. This is one way to analyze it. But I don't suggest this method if your question or figure is complex. Figure is simple, then you can apply it happily. Is it clear? But you should be careful. One small mistake can take your answer. Okay. Every time you take your input ready, take the output. Input, take the output. Then take this input and get ready for the next clock. I told the okay, same way you should analyze. You should not do any confusion. So to avoid confusion, there is another method to solve this question. Is what is J naught here is Q1 bar. What is K naught here? What is K naught here is 1. Then what is Q naught in the next state? Direct formula J Qn bar plus K bar Qn, which will give you Q1 plus Q naught whole bar. This is 0 now. Similarly, what is J1? What is J1 is Q naught, and what is K1? Q naught bar. Then what is Q1 in the next state? J Qn bar plus K bar Qn, which will give you Q naught. Take Q naught common, Q1 bar plus Qn will give you